A mesosphere ends on the end of a light rod, making an angle theta with the vertical. It is held in place by a light horizontal rope as shown in the diagram. So there's a light horizontal rope here. Find a set of values of theta for which the tension in the rope, the tension here, is less than the weight of the sphere. Okay, so in all mechanics problems, it's always good to draw a force diagram. So there's my force diagram. So we have a weight acting down. The good, interesting thing about this question, we have actually no numerical values. So the tension in the rope will let be T1, and the tension in the rod will let be T2. Okay, what can we do? Well, the only thing we really know how to do is to resolve vertically and horizontally. So the system is in equilibrium, so there's no acceleration, that's good. So resolving vertically, so we're resolving this way. So upwards, we're going to have a force of T2 cos of this angle here. And then downwards, we've got the mass mg, and because the system's in equilibrium, that's equal to 0. If we rearrange that, we're going to get that mg is equal to T2 cos theta. We'll call that equation 1. The only other thing we can do is we can resolve this way horizontally. So going this way, we have T1. Going in this direction, we have T2 sine of this angle here. So this component here of the force T2. And that's going to be equal to 0. And then we can rearrange that T1 is equal to T2 sine theta. We'll call that equation 2. Right, so maybe from these two equations, we could probably eliminate T2. And remember, T1 is actually the weight, the tension in the rope. And we're supposed to find a set of values of theta, which the tension of the rope is less than the weight. So we're going to need T1, but not T2. Right, so writing those out again. And there's our diagram. Okay, so what I'm going to do, because I want maybe to get tan, it would be better to do 2 divided by 1. So the equation 2 divided by 1 will be T1 over mg is going to be equal to T2 sine theta over T2 cos theta. Right, so the T2's now cancel out. So we've got T1 over mg and the T2's cancel out. And sine over cos, we've got that's tan theta. And then we'll get an expression for T1. We're going to get T1 is going to be mg tan theta, which is equal equation 3. Right, so we require the tension in the rope is less than the weight of the sphere, and we need the angle for that. Okay, so we need that T1 must be less than the weight, which we can express like that, because this is the weight and this is the tension in the rope. But we've got an expression here for T1, so we'll replace T1 with mg tan theta is less than mg. The mg's will now cancel out, and therefore we'll get 1 here. So we get that tan theta is less than 1. And then we know that tan to the minus 1 of 1 is 45. And therefore the angle must be less than 45 degrees. So this has been a video to show you how to find what the angle should be if we want the tension in the rope is less than the weight of the sphere in a system which is in equilibrium. I hope you've understood, and I thank you very much for watching.